In this problem, we're told determine n for the sum of the series below. And here we have that our first term is 3, we have our second term is 3 squared, our third term is 3 cubed, and then it looks like this multiplicative pattern continues. So notice that if we divide the second term by the first term, we get 3. If we divide the third term by the second term, we get 3, and it looks like this pattern is going to continue. So since there's this common ratio of 3 between terms, that means that this is a geometric series. With common ratio r being equal to 3, we have that the first term a is equal to, the first term a is equal to 3, and n is equal to, well, we're not really too sure how many terms there are in this series, but we know that the sum of all the terms in the series is equivalent to 9,840. So we know that based on the formula that we derived in previous videos, we had that the sum of the first n terms in the sum of n terms in a geometric series is equivalent to the first term times 1 minus r, where r is the common ratio, to the power of n, where n is the number of terms in the series, all divided by 1 minus the common ratio. And this is only for a finite geometric series, so there has to be a finite number of terms. So we know that the sum of all the terms in that series is 9,840, and that's equal to a, which is 3, times 1 minus r, and r is 3, to the power of n, all divided by 1 minus r, which is, again, 3. So we have this equation set up, and let's see if we can solve that equation. Let's see here. So in order to solve this equation, what we're really looking for is we're looking for n. We want to figure out what n is. So let's go ahead and we'll simplify this a little bit. We have that this is equal to 9,840. Which is equal to, let's see, 1 minus 3 is negative 2. So we have minus 3 over 2 times 1 minus 3 to the n. I can multiply both sides by negative 2/3. So let's first, if I do that, that's the same thing as dividing both sides by 3 and then multiplying both sides by 2. And we'll actually divide both sides by negative 3 and then multiply both sides by 2. So 9,840 divided by 3 is 3,280. If I multiply that by 2, I get 6,560. Since I'm multiplying both sides by negative 2/3, I get minus 6,560 is equal to 1 minus 3 to the n. Now, in order to isolate for minus 3 to the n, I subtract 1 from both sides of the equation. So I get minus 6,560, minus 6,561 is equal to negative 3 to the n. So I can conclude that 3 to the n is equal to positive 6,561. And so I'm going to try to write 6,561 as a power of 3. 3 to the power, let's try 3. So in order to do so, I mean, if you know about logarithms, you feel free to use logarithms. But let's just use guess and check. So 3 to the power of 8 is 6,561. Okay, so that means that that 3 to the n is equal to 3 to the power of 8, and thus n is equivalent to 8. So what this means is there are 8 terms, so therefore there are 8 terms in this series. Now, since there's 8 terms in the series, well, let's see here. Notice that to the question is, determine n for the sum. This should actually be determine k for the sum of the series below. So we're looking for k because there's no variable n in this series. We figured out what n is, and we figured out what the number of terms are. But the question should have asked, what is the value of k here? So the value of k in the sum, let's think about this. We have that there's 8 terms in the series. So we have that t sub n is equal to a, which is 3 times 3 to the power of n minus 1. Now, k is going to be, we can rewrite this as in our series, we know that the nth term is going to be equal to, if we just add the exponents, because the bases are the same, we get that t sub n is equal to 3 to the power of n. So what that means is that in this series, t sub 8 is equal to, so that's the 8th term, t sub 8 is equal to 3 to the power of 8, and therefore k has to be equal to 8. So the value of k in this series is 8.